Welcome to the How to Program with Java podcast, where all you need is the desire to learn, and you too can become a Java programmer with absolutely no knowledge of programming. And now, your host, Trevor Page.
Hey guys, thanks for coming back and listening to this episode of the How to Program with Java podcast. As always, I'm Trevor Page. I'll be your host for the show, and we have reached episode number 48, which is obviously fantastic. Before we jump into today's content, which will be continuing on the line of SQL, I'm going to jump into a couple of 5-star reviews that came in. So if you yourself want to leave a rating and review, that would be awesome. I read them at the top of each show. If you leave a 5-star review, I will read it and give you the nod. You can do that via howtoprogramwithjava.com/love, Love. Tell us how much you love the show, and we will reciprocate by talking about you at the beginning of the next show. I say we, but it's really the royal we. It's just me. So 2 5-star reviews came in as of the last time I checked. So they are as follows. We have one from United Kingdom from Emma. Emma says, I just started a course in software development. I'm a novice programmer and thus am struggling with some of the terminologies, etc. This podcast has been a great help, and I especially like the agile development and software lifecycle podcasts. Thanks a lot, Emma. Well, there you go. You're very welcome, Emma. I should probably do some more shows on Agile and whatnot, because I've had a lot of people talk about them and say how cool they are, but there's just so much to talk about with respect to programming. I'll have to loop back and talk more about those things and about my experiences. In any case, moving on to the next 5-star review. This one comes from the United States. From username, let's see, Chandu Veligeti. Who knows? I'm terrible with names, but there you go. They say, Trevor, you are doing a great job. Thank you. I'm an experienced Java developer and absolutely love listening to your podcast every day in the morning while on my way to work, which gives me a chance to brush up on my skills. You are the best. So that's awesome. Great to hear. It's always neat to see the kind of range that I get with my listenership, because even like this person said, they're an experienced Java developer, and they still listen to me ramble on about this Java stuff. So yeah, it's cool to have that kind of audience from brand new people all the way to experienced programmers. So welcome one and welcome all. So let's get this episode kicking. Number 48, we're going to be diving further into SQL. This time I'm going to be following up on the last show where I was talking about aggregate functions. This show, I sort of hinted at it in the last show, but didn't have enough time to move on. So in this one, we're going to be talking about the group by functionality. Now, if you hear me say group by function at some point through this podcast, just ignore me. The group by isn't necessarily a function. I define a function as something like a method that will return some data back to you, some sort of piece of operational programming logic that gives you something back in return. That to me is a function, and the group by functionality is not a function. It doesn't necessarily return you specifically something, but what it does is it sounds like it groups data together. Okay, so that is the sort of, what's the word? That's the point. That's the purpose. There we go. That's the word I was looking for. Man, my brain's not working today. That's the purpose of the group by keyword in SQL, is to take some data and group it together. Now, before I really launch into the content, I actually wrote the blog post for this first, and I find that really helps to focus me and really gets me to figure out exactly how I'm going to go about teaching this topic. So instead of just blindly getting in front of the microphone and spewing my knowledge from my brain through to the computer, I'm taking a moment to type it all out and think about it and find the best way to describe this stuff. And by the end of the blog post, which if you are interested in checking it out while you're listening to this or after, you can go to howtoprogramwithjava.com/session 48. That's where the show notes /blog post will be for this episode. But in any case, I went through the entire blog post, and then finally at the end, I figured out how to explain this in, I guess, the Trevor Page way, which is the visualization way of taking this concept and thinking about it visually to be able to teach it. So I finally stumbled upon that what is it, pot of gold at the end of the rainbow, and now I can teach it to you. So let me start with that, because I found that to be the most helpful piece of knowledge when I was writing the blog post, and it was actually at the very end. So I'm going to start it with it first at the beginning of this episode, and then we'll move on from there. All right, so SQL Group By. Like I said, it's all about grouping data together, mashing it together into groups, and then performing aggregate functions on that group of data. So what is the point of this stuff? Like, why is it that you'd want to mash data together in the first place? Well, so really with this, the example, or at least this can best be explained with an example, but let me try to put it in regular words before we jump into that. So grouping data together allows us to look at the aggregate data in relation to a unique piece of data. Okay, another way to look at it is the rows. You get the data down to just the individual rows. So a typical use case for this would be to group together all the matching data that we have in a database table so that you can get a count of the number of occurrences of that specific data. So a typical example really is, let me think. If you want to, let's say there's an election coming up and you have a bunch of names on a ballot for an election, and people are submitting, let's say they're doing it online, they're submitting their votes online for which candidate they'd want to elect to be the president. Once you have your data submitted electronically and you have the data in the database, then what you can do is you can group together all of the unique pieces of data. So in this case, the unique pieces of data would be the name of the person that you want to elect to become president. There would be a handful of unique pieces of data, group them all together, and then we can tally the votes, or the count is what it is. It's actually called a count, which is one of the aggregate functions we talked about in the previous episode. So you can get the count for each of the unique pieces of data. Okay, that's what grouping is all about. Now, the trick to visualizing grouping, which is what I mentioned already, hinted at, is to think of it like this. If you were to think of each individual piece of data as a bucket, that's the key to really being able to visualize grouping. So think of let's say there's 3 candidates for president. Okay, and of course I'm not American, so I can't think of any presidents off the top of my head. So let me just do the typical examples that I've been using in the past shows of Trevor Page, Jane Doe, and Jack Johnson. Because why not? All those people should be president, right? God, no. So those would be our 3 pieces of unique data. Okay, they're unique in the sense that a whole bunch of people will be voting, but really you can bring all those votes down. You can break them all down into 3 people, one of 3 people, either Trevor Page, Jane Doe, or Jack Johnson. So there we go. We get a whole bunch of votes that go in, but because we only have 3 pieces of unique data, we can imagine them as being 3 different buckets. Okay, so I'm talking a real bucket, like a metal bucket or a plastic bucket, the cylindrical thing that you put something into and it'll hold it in there, a bucket. Hopefully you're familiar with this concept. So we have 3 buckets, and each of them will represent each of the unique pieces of data. So we have a bucket for Trevor Page, we have a bucket for Jack Johnson, and we have a bucket for Jane Doe. Okay, and for each vote that gets tallied, for each insert that goes into our database, we will put it into the appropriate bucket when we do the grouping. Okay, so a vote comes in, let's say it's, I don't know, the table is, votes or something like that is the name of the table, and we have a votes ID. Or a vote ID, I guess would be better to take away the plural. So vote ID. So each vote that comes in has a unique ID, but then there's the name of the person that they were voting for. So if the name is Trevor Page, then we take that specific piece of data, that row, and we put it into the Trevor Page bucket. If a vote comes in and it's a piece of data, let's say row ID number 2. So what is that? Vote ID number 2. That is for, let's say that's also for Trevor Page. So we take that and we put it into the Trevor Page bucket. So now we have 2 rows that exist inside of the Trevor Page bucket. And so on and so forth. Another vote comes in, another row of data, vote ID number 3, and that is for Jane Doe. So then there you go. We can visually picture that going into the Jane Doe bucket, and so on and so forth. So as long as you can sort of think about it visually like that, I think that sets up a really good foundation for the rest of this episode, where you're going to be learning about grouping data. Okay, so it's all about buckets, the individual, what you can boil all the data down to individually, and putting each row into a particular or the appropriate bucket that best represents that data. Okay, so let's see. So, well, like I said, grouping and counting is actually a very simplistic use case for the group by keyword. We're just talking about counting votes. So the example that we're going to be talking about in this episode is going to be related to bank accounts and transactions. Okay, so with bank accounts and transactions within those bank accounts, we can really start to use more complex grouping methodologies, which is, of course, what we're going to be learning about today. All right, so all right, why should we use this group by stuff? Why should we use the SQL Group By keyword or functionality? Well, it's extremely valuable in many, many ways. So like I said, we're going to talk about an example that relates to bank accounts and transactions within those bank accounts. So let's assume that we have 3 different bank accounts. Okay, just like I said, we have 3 different people to vote for. Now I'm switching it to be bank accounts. We have 3 different bank accounts that belong to whomever. Doesn't really matter in this case. And each bank account will have their own transactions. Excuse me, either a debit transaction or a credit transaction. Okay, debit means purchase. Credit means essentially income or a positive balance coming into the account. Okay, in the real world scenario, credits are good. We want lots of credits. We want more credits than debits because debits means we're spending all of our money. So for this example, we have bank accounts and whatnot. We'd love to see a summary, like a quick summary of all the credits and debits for each bank account. Let's say that that's a requirement that someone hands to us. They say, okay, Trevor, I want you to write a query that will give me a summary of all the credits and debits for each of the bank accounts. Okay, that kind of requirement, that kind of demand, if you will, lends itself perfectly for grouping data. Okay, so let's take a look at our first example from our database. So first we'll create a database. And like I said, all this will be available at howtoprogramwithjava.com/session48. You'll be able to go there and you'll see the actual code that I'm using to create our database tables. So let's see. The first table that we're going to create is obviously bank account. Okay, so this bank account table will have the primary key, which will be bank account ID. And it will have a bank account number, which let's just assume it's a varchar. Let's assume it can be alphanumeric. It can have obviously both alpha characters and numbers inside of it. And that'll be the bank account table, nice and simple. Then we'll also have a transaction table because each transaction should be tied to a bank account. So if each transaction should be tied to a bank account and only one bank account, right? You wouldn't want to have one transaction be tied to 2 separate bank accounts because that would be kind of weird. Well, how can you have a purchase come out of 2 different bank accounts, right? You would probably have 2 different transactions if that were the case. So because that's the sort of rule, then that is a one-to-many relationship. One bank account can have many transactions, and any given transaction from the many side of the relationship can be mapped back to one bank account and one bank account only. So that's a one-to-many situation. So because we have a one-to-many relationship, this is what our transaction table is going to look like. We're going to have a transaction ID, which is typical. We're going to have a primary key of transaction ID, fair enough. We're going to have a bank account ID, and that's going to be the foreign key inside of our transaction table. It's a foreign key because, like I said, we have a one-to-many relationship, and that's how we set up a one-to-many relationship. We put the foreign key of table A into table B, and voila, we have a one-to-many relationship. Again, if you don't know what the heck I'm talking about, you can go back a bunch of episodes now, probably, 4 or 5 episodes when I start to talk about keys and whatnot and relationships and databases. So, okay, so we have a bank account ID, and that'll obviously be an integer, and we can have a transaction date, so the date at which the transaction actually took place. For now, I'm going to keep it simple and just make it a date, not a date time type. Although probably date time would make more sense because typically you have a time, obviously, time frame of when the particular transaction happens. But again, I'm not creating this to be a real world scenario, so date will do just fine. And let's see, so I should also have a debit amount. Okay, so there's a debit amount. So for the actual transaction itself, It could have obviously an amount for the debit transaction. And we're going to make this a numeric data type. Now, we've actually never seen this one before in this particular line of SQL tutorials that I've been putting together. We'll make it numeric, and with a numeric type, you can actually assign essentially how many, how big the number should be, as well as how many decimal places it should hold. All right. So for this one, I'm going to say it can be up to 10 digits in length. So and it can be up to it should be 2 decimals of precision. Okay, so that's a typical monetary value. At least in North America, our money is typically rounded to 2 decimal places. Okay, so we'll have up to 10 digits of size and 2 digits of precision. So that way it'll be a numeric data type. So numeric, and then in brackets it'll be 10, 2 to represent the size and the precision. Cool. And then I'm actually also going to assign a default value as well, because I never want these fields to be null. I want them to be $0.00 as a default. So a transaction of $0.00 means nothing essentially has happened. So we'll just assign that in as the default value just to be safe. So that'll be the debit amount column, but I'm also going to create a credit amount column with the exact same things I just said. It's going to be a numeric with 10, 2 as the size and precision, and I will make it also a default of 0.0. So I'm splitting them up into 2. So I split up the debit and credit amounts into 2 different columns for a particular transaction on purpose, because I want to be able to group by them individually later on. So that's sort of why I set it up like that. Plus, when you look at your statements, you can normally tell which ones are debits and which ones are credits, because they're usually stored in 2 different columns. Like in your, if you were to look at your bank account statement, they're typically in 2 different columns. At least mine are. So that's sort of what I'm mimicking. I assume since they do it that way, that's the way that it should be done, because they're banks and hopefully they're doing things the right way. So. Okay, there we go. So that's our transaction table. That's our bank account table. So now we can go on to actually insert and populate our tables with some values. Now, like I said, just check out the actual post on howtoprogramatjava.com/session48, and you'll see exactly what data I'm putting in here. But I essentially insert into the bank account table 3 different bank accounts. We'll just call them A, B, and C for the sake of simplicity. And that'll obviously be bank accounts 1, 2, and 3. Whatchamacallit? What's the word I'm looking for? God, my brain's not working today. In any case, bank accounts 1, 2, 3, ABC. Those can be synonymous with the bank accounts. And also, we want to insert into the transaction table. So we insert into transaction table. I think I've put 1, 2, 3, 4, 5, 6, 7 different transactions into the table, and they're all they flip between being debits and or credits. And I assign some dates, to them, sort of 3 different dates, and sort of sprinkle them around. Okay, so just one for let's say the first one is tied to bank account ID number 1, and it's for a credit amount of $250.12, and it was on the transaction date is June 10th, 2014. And so on and so forth. It doesn't make sense for me to go and read off every single transaction in the table, because it will just be me, droning on and on and on about what data is in there. So 7 different transactions I'm putting into our example database tables. Or table, I should say. So, cool. We're done. There we go. We've inserted the transactions. You can do it yourself. If you want to, go to the post. You can copy-paste it and create your own database tables and insert your own transactions. So there we go. So with all this data, what can we do with it? Well, it's like I said, it's a bit easy to get lost in the details of what's going on. So wouldn't it be nice if, instead of looking at a bunch of transactions, wouldn't it be nice to just be able to break down the balance of each account based on all the transactions in the table? It's actually pretty simple to do that. I don't even think we need to use a group by in that case. We can actually just perform a sum operation on the credit amount and the debit amount columns. Okay, you've already learned how to do this as part of the aggregate functions with the sum functionality. But the twist here obviously comes into play when you want to know not the entire sum, like you don't want to know the entire the overall balance of all the accounts as a whole. Okay, if you want to learn the actual balance of the entire, all of the accounts together, which wouldn't necessarily make sense from an individual person's level, unless an individual person, I should go back on that word, on what I just said, because let's say I have 3 different bank accounts and I want to know how much money I have in total, because maybe I have a bank account that only is like a line of credit, so all it is just debits that I'm making, and maybe another one is where I'm making some debits and some credits, where maybe an account where I'm collecting a paycheck as well as making some purchases, and then maybe a third one that's just a savings account or something like that, where I'm only putting credits into it. So in that case, it would be helpful for me to know what the entire total, I want to know if I'm in debt or if I have money, what's going on there. So in that case, we would do a sum on all of the credit and debit columns, right? So I could actually just say select sum, and then I could say credit amount plus debit amount in brackets. Okay, I can actually perform a sum within a sum, which is kind of neat. So I get the sum, open bracket, credit amount plus debit amount, and I could say from bank account, and I think that's all I would need to do. Let me actually run that code just to make sure I'm not losing it. No. I actually need to do one more thing, because the credit and debits amounts are actually stored in the transaction table. So I'd actually have to join my bank account table to my transaction table in order to be able to, add those things together. Because like I said, the bank account table only has bank account information. It doesn't have the transaction information. So like I said, we'd select the sum of credit plus debit from bank account, and then we would join transaction on the bank account ID from both tables, okay? Because the bank account ID exists as a primary key in the bank account table and as a foreign key in the transaction table. So when I sum them together, I can get an idea of what the entire balance is. So in this case, for my example, if this is correct, I'm hopefully it is. The amount that I get is $1,400 or $1,454.73. So $1,454.73. Okay, it doesn't really matter to you on the other end of this if you're just listening through audio, but it'll make a lot of sense when you actually go through the example that I've laid out. Okay, so that's great. So now I know at a glance that I have positive cash flow, I guess is the word I'm looking for there. That's a great thing. I love to have positive cash flow. But let's get a little bit more fancy here. We're already familiar with doing that. I want to get more fancy, and I want to be able to see the actual amounts for each individual account that I have, because obviously that is useful as well. We want to know what our balance is in our line of credit and in our savings account and our checking account and so on and so forth. We want to know what the individual balances are. So how do we do that? Well, that's where this grouping thing comes into play. Okay, so now let's get our minds, our brains going here, the eye inside of our mind, and start visualizing what's going on here. I want to group the data by the bank account, okay, the actual bank account number, if you will. So each of my bank accounts, I have 3 of them. Let's call them A, B, and C. Those are my bank account numbers for my 3 bank accounts. And I want to figure out the balance of each. So I need to group the data into the buckets. So I have bucket A, bucket B, and bucket C. That represents each of my bank accounts. And now I want to go through each of my transactions. So in my example, let me just pull up my example again. Let's see. In my example, my first transaction is towards bank account ID number 1, which is bank account number A. So fantastic. So I'm going to take that particular transaction and put it into the bucket A. My second transaction is a debit amount of negative $123.93. So I put that into bucket B because that's going into the bank account B. And then the third one for bank account C goes into the bank account C bucket of $832.11. Okay, great. So now we have one transaction in each bucket. Okay, great. But we need to keep on going because we're not done with our grouping. Okay, we're grouping all the transaction data together. At least that's what my query is asking it to do. So I want to get all the data. So I keep going. The next one I have is back to bank account A again. So bank account ID number 1. This is a debit amount for a negative $100.32. So I take that and I'll put it back into bucket A. So now I have two transactions, hypothetically speaking, or metaphorically speaking, in bucket A. Okay, one for a positive amount of $2.50 and some cents, and one for a negative amount of $100 and some cents. And then we repeat, then there's a transaction for bucket B and a transaction for bucket C, and yet another transaction for bucket A. Okay, so we end up, the final picture is we have 3 transactions in bucket A, 2 in B, and 2 in C for a total of 7. But now we've grouped them into our individual buckets. Okay, so now let's just visualize them sitting there, floating there in their buckets, all happy, doing whatever it is that transactions would do. This is getting a little cheesy, I apologize. And now what we need to do is figure out the sum of the transactions as they are grouped inside of their individual buckets. So that's what we're doing here, okay? We're summing up the amounts inside of their individual buckets. Now, how we do that is we write the exact same thing that we wrote before, the exact same query, only the difference is we want to add a group by clause at the very end. Okay, so we're going to say select, this is going to be exactly the same as before, select sum of, let's say, t.credit amount, because we want to have I'm going to give an alias. So the alias for the transaction table is going to be t. So I'm going to say sum of t.credit amount plus t.debit amount, okay, from bank account, and I'll call it B as an alias. And I join the transaction table T on T.bank account ID equals B.bank account ID. That's just typical stuff that you've seen before. That's how you join tables together. No biggie. But now we say group by B.bank account number. And it's important to understand why I chose the column that I chose when I'm grouping my data together. Because remember, I said we have the buckets, and the buckets represent the bank account numbers, A, B, and C. So because I'm grouping in my mind based on the bank account numbers, A, B, and C, those are the buckets I've created and putting transactions into, that's what we need to say in our SQL query. We need to say group by B.bank account number. Make sense? Hopefully it makes sense. So, great. So now we have that, but I also want to get one more piece of information, because if I just run that query, all I'm going to get is the 3 different amounts, which are just 3 different numeric amounts, but there's no data that tells me which amount goes with which bank account. So we also want to select, we want to add a one more column to our select statement. So instead of just saying select the sum of t.credit amount plus t.debit amount, we also wanted to put a comma in there and say b.bank account number. So when we do that and we run that transaction, it will select and show us the individual bank accounts. So again, because we're grouping on bank account number, we should not see any duplicates here, because it won't do that because it's grouping them together by that particular column. So we'll see each of the unique bank accounts numbers, A, B, and C, but we will also see the corresponding sum for each individual bank account. So no longer do I have an overall sum of whatever it was, $1,492. Now that whole sum is broken down into 3 different sums of money that individually add up to the $1,400 whatever total, but they're individually assigned to their bank accounts. So on bank account A, I have $292. In bank account B, I have $198. And in bank account C, I have $964, which all obviously together add up to the sum which we had talked about previously. But now, like I said, they're grouped together individually into their bank accounts. And that is a very useful thing to be able to do. We've taken 7 individual transactions and we've grouped them into just 3 rows of data. So now let's expand that. Instead of having 7 transactions, let's say this is the transactions for an entire year. Okay, I don't know how many transactions people shell out on their daily or in their daily lives. I can't even imagine. So let's say over a course of a year, which is 365 days, let's say someone has accumulated 2,000 transactions. Okay, you have 2,000 rows of data. How in the heck are you going to be able to go through that and decipher anything meaningful from those transactions? Well, what we can do here is, like I said, we can group them together. It's the same exact piece of the SQL code or SQL query that I talked about to actually group them all together and get the individual totals for each of those accounts across an entire year's worth of data. It does it lickety-split, no problemo. It's a little bit slower than performing an individual select because it has to do some extra number crunching behind the scenes, but 2,000 rows of data for SQL is nothing. That's chump change. It can do that in no time flat. So it's the exact same SQL query, but now you can see how that is really quite useful. So instead of dealing with 7 transactions, we're dealing with 2,000, and they will all be boiled down and placed into their individual bank account buckets appropriately, and it'll then calculate the sum for each of those transactions. Because remember, each transaction can have either a credit or a debit amount. So not only is it putting the transactions into the bucket, but it's also doing and performing an aggregate function on each bucket of data. So when we look at bucket A, it's going to go in and it's going to actually sum up every single transaction, whether it be a credit or a debit, and then boil it down to give you that final correct sum of all of those transactions for that particular bank account. So that's why this stuff is so cool and it's so useful, because you're essentially taking, like I said, one piece of data and you're creating an entire new piece of data from it. You're using your scientific mind to be able to translate it into potentially more human readable data. Because again, you can't look at 2,000 transactions and pull something meaningful from just looking at that. But you can pull something meaningful from looking at 3 different bank accounts and saying, here's a total for that one, here's a total for that one, and here's a total for the third one. Much more human readable. Okay? Whew, cool. So, and I mean, eventually what you can do here is you can get even more, tricky if you like, and you can break it down. I guess it's not really that tricky. You can break it down into the individual sums of the individual debit and the individual credit amounts if you like. So instead of having the lump sum, you can actually just look at the total purchases versus the total, credits, right? The total debits versus the total credits. You can split it up into 2 individual sums if you like. So you can say select b.bank account number, comma, sum of the t.debit amount, comma, sum t.credit amount. So you can actually have 2 different sums in there, and it'll give you 2 different columns and only add up the debit amounts in one column and only add up credit amounts in the second or third column, whichever way you want to look at it for your columns that are displaying on your screen. But in any case, that's a further way to break down the data if you like. Okay, so there's some important things to know there. Since we're grouping by bank account number, we're allowed to put the bank account number in the list of columns that we're selecting from. That would make sense. So, like I said, since we're doing group by bank account number, it's okay to say select bank account number. Okay, and like I said, since we're using the group by keyword, we're also allowed to use aggregate functions in our list of columns that we're selecting from. So we can say select sum of whatever, or we can say select average, or we can say select count. Okay, all of these things are valid, perfectly usable things that we can put into our select statement when we are using the group by functionality. Okay, perfectly legit. Where things get a little bit tricky is if we start to use columns in our select statement that are not in our group by list of columns. Okay? Sorry, I should amend that. When we should get a little bit hesitant to put columns into our select statement if they are not part of the group by and they are not part of an aggregate function. Okay, so not part of a sum or a average or a count or what have you. If it's just a random other piece of data that we're putting into our select statement, one of 2 things could happen. It could actually, I think there's sometimes it even says, sorry, I don't know what you're talking about. I can't do that. I can't show you that particular piece of data. But I mean, that might not happen a whole lot. The one that will happen is you'll see a piece of data, but it's going to be a little bit misleading. So a good example of that is, let's say we take our existing example of summing up the debits and credits and breaking it down by grouping it by bank account number, but then we put in the transaction date inside of our select. So we select the transaction date as well as the bank account number and the sum of the the bank accounts, with the debits and credits together. If we put the transaction date in the select statement, we'll see a transaction date, but it's probably going to be the first transaction date that it hits for that first transaction, or that first row that it puts into that bucket. So for example, the first transaction that we grabbed and put into bucket A when we were talking about our credits and debits and grouping them together, the first one was for, like I said, bank account A. It was a $250 credit amount, and the transaction date, which I'm not sure if I said it or not, I said it was June 10th. That's likely what will show up when we say select the transaction date. Okay? But don't forget, there could be another, like I said, 500 transactions in that bucket that could have a whole bunch of wide ranges. It could be, 499 different transaction dates. But the one that'll show up is just that first one that you put in. Or it's the last one, I forget which it is, because obviously I don't do that, because that's misleading. That's not a useful piece of data to get back from our grouped data. It's not useful for me to know that transaction date, because it only pertains to one particular transaction inside of that bucket. Okay, because the data changes between each of the transactions in that bucket, so it gets a little bit crazy. So if you wanted to see the transaction date and you wanted it to be meaningful, this is where we can get a little bit more advanced, and we can actually break it down into grouping by 2 different columns. And that's legit. You can totally do that. That's perfectly fine. You just need to understand what sort of results you're going to be dealing with, okay? So if I wanted to actually show the transaction date as well and select by it and group by it, then I would put it in my select statement and my group by statement. Everything else would remain the same. So now my example would say select b.bank account number, comma, sum of t.credit amount plus t.debit amount, comma, t.transaction date. Okay, so we're putting the transaction date in there now. This is from bank account. We will join the transaction table using the transaction joining SQL code that I've talked about before. I don't want to confuse you with it. And then we do a group by b.bank account number, comma, t.transaction date. Okay, and I think the order matters. I think I'm not positive. Let me just go ahead and tweak my code here to see if I get different results. Let me see here. It looks like the results change depending on the order that I'm grouping by. So it's almost like we group by one bucket first. The first one in our group by is what we group by first, and then the second one is what we group by second. So you see how the data could sort of change depending on which one you're grouping by first. So obviously, whichever one you have listed first, it's going to group by first. But in any case, you're going to group by bank account number, and then I guess what you can visualize it as is you have your bank account bucket, and then within that bank account bucket, you have transaction date buckets. Okay, and there'll be as many transaction date buckets as there are transaction dates that go into that particular bank account bucket. Okay, kind of confusing to say, but let me look at it this way. What will happen is it will take the transactions that belong to bank account A, and it will, let's say, place them or hover them above the bank account A bucket, and then it looks at the specific transaction dates for each of those transactions that should go into the bucket A, but it looks at them and says, okay, what's your transaction date? And it says, okay, the first one is, like I said, June 10th, so I'm going to put it inside of the June 10th bucket, inside of the bank account A bucket. All right, makes sense? And then I'm going to take another transaction that should go into bucket A and look at the transaction date. This one is June 12th. So I'll have a second transaction date bucket and place it inside of that one, which is inside of the bank account A bucket, okay? So we have 2 buckets inside of one. So that's sort of how the multi-grouping functionality works inside of SQL. And the result is it will break it down into 2 rows of data for that particular bucket. So instead of having just bank account A appearing once, it's actually going to appear twice, and it's going to properly sum up the totals depending on the transaction date bucket. Okay, so let me open up my, again, it's tough to portray this through audio, but let me open up my my examples. So for bank account ID 1, we had a credit of $250 on transaction date June 10th. Okay, but we also had another transaction which was a debit of $100.32 that also goes into bucket A with transaction date of June 10th. So what happens is it's going to take those two, they're both going to go into one bucket, and then it's going to do the sum on the aggregate function that we asked it to do on those two transactions. Okay, so it's going to take the $250 and then it's going to take the $100 or the negative $100, add them together. So we're going to get, instead of $250, we're going to get $150, okay, and some cents, whatever the change is. And that's going to go into our row of data that's going to get returned. Okay, so that's how it sort of breaks it down and then applies the aggregate function on it. So how you should visualize it and how you should picture it and how you should think about how this works is it always tries to put the data into the appropriate bucket first, and then it runs the appropriate aggregate functions that you have asked it to run on that data within that individual bucket, wherever that bucket may or may not exist. Okay? Whew! So there you go. I think that's a good rundown, a good example, an explanation of how SQL groups data together and puts them into buckets. And actually, now I say buckets, you're not going to see pictures of buckets in your resulting SQL queries or the results in your whatever I guess quote unquote IDE that you'll be using. I guess it's not an IDE, whichever visual representation that you're using for your data. You're not going to see an actual bucket. You're just going to see rows of data like you've always seen whenever you've done a select on that data. It's just that data is going to have different, most likely different, what are they called? Headers for each of the columns to describe them. So I mean, like I said, when you have a bank account number and a sum and a transaction date, you'll see bank account number and it'll list them out. And for the sum in Toad for MySQL, what I'm using is the header that it says that gives to it like sort of the title for this column. It puts sum. It actually types out sum bracket t.credit amount plus t.debit amount, and it closes the bracket. Okay, so that's going to be the title of our column of data. If you really wanted to change that, if you don't want to say sum and all that stuff, you can actually, beside the sum in the select query, you can actually type in, sum, like I said, blah, 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 and then you can say as, and you can type in the name that you'd like to give to it. So you can say as, let's see, total. I'll call it total. And then if I run that, then now that column is named total, and you can actually refer to it as total throughout your SQL query. Okay, just a little tidbit, a little nice to know piece of information that I'll tack on to the end of this lovely tutorial about grouping data. So, like I said, you can check out all those examples. You can check out the full blog post where I go into detail about this stuff at howtoprograminjava.com/session48. I'd love for you to go there, and I'd also obviously love for you to leave a rating and a review for this particular podcast, and I'll read your rating and review, any 5 stars, on the next episode. You can do that by going to howtoprogramwithjava.com, gotta remember the .com, /love, LOVE. Leave your rating, leave your review. I'll read it, top of the next episode. And it really helps us to get found whenever you do that. Whenever anyone leaves a good review and a good rating, it just helps spread the word and help more people find these episodes and join our little family, our growing family of programmers learning about the Java programming language. All right? Awesome. So as always, before I go, I will urge you to check out, when you're going to check out that blog post, sign up for my email list on the top. Usually I'm running webinars or workshops. They're completely free. I teach a whole bunch of different topics. I actually wasn't able to put up the next workshop just yet because there was something that threw off my schedule last week. But soon I'll be introducing the next workshop. I'll be emailing you guys to ask you what it is that you guys want to learn about. So if you're hearing this episode live on the day it was recorded, which is June 16th, 2014, although it might go live on June 17th, 2014, then by all means get on the mailing list, join, and you'll be receiving an email from me asking you what it is that you want to learn about next, and you'll see, I'll put it in I'll do a survey for it. and you'll be able to vote, and then I will obviously pick the one that's the most popular and teach whatever topic it is that you guys want to learn about. So if you want to say, go there, howtoprograminjava.com, even /session 48. At the very top, you'll see an area where you can either type in your email address, or you can click there and actually join the next free live online workshop where you will learn whatever awesome, piece of information it is that you need relating to programming in one way, shape, or form, whether it's SQL or Java or something completely different, maybe HTML, who knows, right? I don't know, whatever it is that you guys want to learn about, I will teach. So yeah, go ahead, hop on the email list, and you'll get that email from me shortly. Plus, you're also going to get a cool little PDF I put together on the top 7 tools that Java professionals actually use. So it's a nice little one-page, quick hit PDF where you can actually go and download all the tools. And I think 85% of the tools on there are free, which is awesome. It's a great time to be a programmer because everything is free. So go to howtoprograminjava.com /session 48. Get all those goodies and get that email from me with respect to the survey, and then you'll be able to choose what it is you want to learn about and all that good stuff. All right, so until next time, I wish you the very best. I wish you happy learning, and I will say bye for now. Cheers.
Welcome to the How to Program with Java podcast, where all you need is the desire to learn, and you too can become a Java programmer with absolutely no knowledge of programming. And now, your host, Trevor Page.